Right, to the surprise of absolutely no one, I haven't recorded a video in a while, so I thought I'd do a quick one. I've decided to have a mess around with some methods of controlling synth circuits with an Arduino, because it was something I was going to do like probably 18 months ago and never got around to. So I figure I'm just going to put some circuits together and kind of report back on how it goes. So yeah, we'll see what happens. Right, this is the first one. So I'm just using Nano because it's one that I had lying around. I think everything else, all the others I've got, I'm currently using for stuff. So the Nano is the one that you just kind of have to put it on a breadboard. But it does most of the same things that the other ones do. So what I've done, I've set up an oscillator circuit with a 40106 down here. So I've got this is one of those kind of LED photoresistor, voltage controlled resistor things that I've bodged together. So that's controlling the pitch of the oscillator, and then what I've got is the Arduino is sending an output to make the LED fade in and out. So it uses pulse width modulation, so it's not quite the same as driving it with a voltage. So I was expecting this to not work very well, and I was not disappointed. It doesn't sound great. I'm going to see if I can see if this picks up alright. So that's it. I've just kind of got it set to fade in and out, so it's sweeping up and down frequencies. I had a mess around swapping out the capacitors for some different values, but hopefully that you can hear that and it comes out alright. But it's got some kind of, it's really noisy. So I did have a look about making basically you can use a low pass filter to turn that PWM output into an analog one, which is what I've attempted to do by adding that resistor and that capacitor. And if I remember, I'll put in a link like here to the site I was looking at, and it seems to change it slightly, but it didn't really. So what you heard earlier was with that part included. And if I just take it out, it's pretty much the same. What happens if I bypass that resistor? Hopefully I'm not gonna. Oh man, I've just unplugged something. Oh, it's only that. What have I done? Oh, I've ruined everything. You know what, I'm going to move on to my next idea. Right, next one. So this one is using a TLC 5940, which is this thing here, and that's an integrated circuit that lets you, it basically gives you, I think, 16 PWM outputs from 5 outputs on your Arduino, and then you can daisy chain these so that the same 5 outputs on here, you can just keep adding them on and adding more. I was just interested to see if it was any difference. It's still PWM, but you know, in the interest of experimentation, I thought I'd see if it changed it, but it doesn't. So that's a bit of a pain. These things are very cool if you have a project where you want to either control tons of LEDs or servos, or if you want to do if you have like RGB colour mixing LEDs. I put this thing together ages ago just as a test, so it basically allows, they're all like, they'll do any mix of colours, and you just bang the IC in there and connect it up. It's a useful bit of kit, but not for controlling oscillators, it turns out. Oh yeah, and I if you want to use one of these with your Arduino, there's a bunch of libraries you can grab off GitHub. So I will try and remember to put a link to the one I used here. It's just occurred to me that I probably should have tested this circuit before without any Arduino involvement at all, so I'm just going to make sure that it does work. So I've just I've disconnected the power. I was getting power from the Arduino, so if I do that, oh, I didn't turn it up. No, what the shit? What have I done here that's dumb? Oh, that's why. That's. I haven't totally unhooked it. That was still grounded to the Arduino. Let's try that. Still doesn't sound great. So that's alright with that. I think. Yeah, I've got some of these things. So let's just pull that pot out of there and shove one of these in. I need something that makes light. This thing. So that sounds fine. So do I just have to keep the power separate? Right, okay. Next test is I'm gonna see what happens if the oscillator circuit isn't powered by the Arduino at all. I'll power that off a battery and I'll just do the LED with the Arduino, so right, I'll report back shortly. Right, so I've kind of isolated the power, so this circuit is just being powered by that battery and not from the Arduino, and it does sound better. I now don't have a resistor before the LED that's in there now doesn't have a resistor in front of it, which might have made a difference. So it's not perfect, but I think it sounds better. And the other thing I wanted to try is just swapping out this capacitor for a smaller one. If I put this back on there, without destroying everything, preferably. Oh my god, everything's going wrong. So if I do that, just while I quickly grab that. Try and jam that in there. Now that doesn't sound great now. So it seems to be when it's at kind of higher pitches. Oh, hang on. Oh yeah, it was clipping the input a bit, but that's not what caused the problem. Because now it's not clipping. Right, so that's also a no-go. So I do have some digital resistors somewhere. Digitally controlled resistors. So I'll go and find them and see what I can do with that. Okay, I got this one set up. I got these digital potentiometers. I call them digital resistors. They're not digital potentiometers. This is a X9C103P. So I've not really properly messed with these. So I found a sketch that someone had uploaded, an Arduino sketch, which I will put a link here. So I've hooked it up. So it's the it's that little thing in there. Is the digital potentiometer, and so this sketch that I found, it basically just runs it down from its highest value to its lowest value and back up again. So I'm going to do that now. In fact, you can actually hear that's it at its highest value, and as soon as I send the thing to start it, so it kind of sounds fine across the whole range in terms of there aren't no kind of weird digital artifact sounds, but obviously once it gets to higher pitches you can hear the steps. Now that's because there's only 100 different values that it can be, and so when you're at higher frequencies, a smaller change in resistance makes a bigger change in the pitch. I think I got that right. It does it for reasons. So yeah, so this one has 100 values, so I guess that as it stands is probably usable for some purposes. I mean, it covered a decent range. But the fact that there's only 100 steps, so that's not great. So I probably need to find, see if there's one of these that has more steps, I guess. Yeah, I'm gonna do a bit of googling about that, and maybe make a purchase. In fact, I'm gonna look at that now. One last thing to show off. Nothing to do with synth circuits. I just something I've been screwing around with on a week off work, and it's really cool. So I've made this little turret. It's got a laser pointer on it. I don't know if you can see. Can you see the dot over on that thing over there? But it's the control method that I've got going at the moment. Is this. So we've got left, right, up, down. Look how cool that is. It's actually kind of reasonably accurate once you get used to it as well. But one of the cool things about it is I could use this control method for anything. The fact that I hooked it up to that turret is kind of just because that's what I was playing with, but basically this has just got if I can get it out of here, I've just got this. It's a Spark Fun chip, 9DOF. So that kind of senses rotation and movement and whatnot. So yeah, I'm going to try and work that in as a control method for something once I've got, well, hopefully these digital potentiometers working. So I've just ordered one with a higher resolution, so it should have more steps, and hopefully that'll work. So yeah. Ugh. So I just need to figure out my superhero name, and yeah, right, lighters.